Hello everybody and welcome back to more of our 2019 Manitoba Math Contest. What have we got for question number 8? If the square root of x minus 13 and square root of x plus 20 are both integers, find all possible values of x and prove that no other values are possible. Okay, I think I've seen a question similar to this in the Crux Mathematicorum publication. So that if you haven't heard of Crux before, they're good to know. Actually, I'll write it down. Crux. I mean that's how it's spelled. I can't remember if they still have the Mathematicorum on there from when I was young. But Crux is a good sort of little math magazine. It comes every couple months, and it's got fun math problems in it. And as I say, I think there was one similar to this. I think it might have had different numbers in it. It's got other fun problems and discussions about math in it. Anyways, I can see right away that x plus 20 is greater than x minus 13. That's just how numbers work. So there's not too much of a worry. And we also know that these have to be greater than or equal to 0. Otherwise, you can't take the square root. Remember, this symbol means the thing under it has to be positive, and the thing that you get out is also positive. Okay? So, we want values of x that make this work. Well, if the square root of x plus 20 is an integer, maybe call it a, and the square root of x minus 13 is an integer, maybe call it b, I can see a has to be greater than b. Okay? But what happens if I square them? Well, if I square both sides, I'll get x plus 20 must be a perfect square, and x minus 13 must be a perfect square. So whatever x is, it's between two perfect squares, but we can actually go a little bit further. I don't quite know what a squared and b squared would be. I don't know what a and b necessarily have to be. But I do know that I can take their difference here. On the one side, I'll factor to a difference of squares. And the other side, if you do the subtraction, the x's cancel out, and it doesn't matter what x is anymore. You get 20 minus negative 13, which is 33. Okay? Now, a and b are both non-negative integers. And we know a is bigger than b, so a minus b is greater than or equal to 0, so is a plus b greater than or equal to 0. And because we can factor difference of squares, what we must be looking at is two integer factors of 33. Well, I know that 33 is 3 times 11. So we get... we have only really two possibilities. Will each lead to an x? I don't actually know. We know a minus b needs to be the smaller of the two. Okay, if you want to, you could probably point that out somewhere. I don't think it really merits mention, but if you're worried that somebody's going to say, well, how do you know this one's the 1 and this one's the 33, then you include it. But what we can do is we can sort of list out the possibilities of what a minus b and a plus b are. And from there, we can actually find a and b. And if I know a and b, well, I know x plus 20 should be a squared, or x minus 13 should be b squared. So we should be able to work out x from there. We'll do a squared, and then we'll do x, which should just be whatever's in this column minus 20. Okay? So we could have 1 and 33, 3 and 11, and those are the only sort of pairs of factors of 33 that you can really have. This question would be harder if not 20 and 13, but they had something where the 20 plus 13 had more factors. So, if they did 60 and 4, then 64 has a lot of different factorizations. There'd be a lot more possible a's and b's. But how do you get a from all this? Well, if you take a minus b plus a plus b, the b's cancel out, and you're left with 2a. So 1 plus 33 is 34, divided by 2 should give me a, 17. And the difference between A and B is 1, so B is going to have to be 16. Similarly, if you take the 3 and the 11, that adds up to 14. Divide by 2, you'll get A is 7. And the difference between A and B is 3, so B would have to be 4. So A squared would be 289 or 49. Subtract 20, you'll get 269 and 29. So I know these are the only possible values of x. So these two are correct. But they also said, well, explain why there are no others. There are no other possible x, as there are only these two factorizations. I guess you could say of 33. But that's it. So 269 and 29 are the only answers. And if you want to, you could even, double check. So I know 269, if I add 20, I get 289. That's 17 squared. If I subtract 213, I'll get 256, and that's 16 squared. And if I take 29 and I add 20, I'll get 49. That's 7 squared. If I subtract 13, I'll get 16, and that's 4 squared. And that's it. Nothing else that we need to worry about there. Okay. So, yeah. I think that's it, and I think we've been clear along the way. And we also, we said a couple times we only have these possibilities for factorizations, and there's no other order, because as we've already remarked, a minus b has to be less than a plus b, so I think we're good. We're good to go, and we are ready to move on to our next question. That'll be question number 9.